Welcome to the Cosmic Pie Podcast, episode number 27
for season 3.
for season 3. That's pretty good.
That's
Good
pretty
achievement.
I think it's brilliant, but
So we are broadcasting live here from the campus of the University of North Dakota here in Grand Forks, North Dakota.
I suppose we should introduce ourselves.
Go ahead,
I'm
Robert.
Robert Moore.
I'm Wayne Barkhouse.
Yep. So the only other thing to get rid of right off the bat is me talking. To do our disclaimer.
You want to do the honors again?
Sure. Our disclaimer is the usual. The opinions and everything stated in here in this podcast are those of myself and Wayne, not the University of North Dakota or the Department of Physics and Astrophysics or any other entity on Earth. So we may be speaking for Jupiter.
The god?
I don't know.
Not the planet.
Might be speaking for the planet. Who knows?
Now, we do have a live chat feature that's running, so if you have any questions or comments throughout the podcast, please do not hesitate to send us that information, and we will stop what we do on the spot and try to address your questions, unless it comes at us at too fast of a rate, and then near the end of the podcast, we won't have time to answer it. But we should suggest, if you have any ideas of different topics you'd like us to focus on different podcasts, I mean, feel free to let us know.
Feel free to let us know. Either drop us a comment or drop a suggestion in the chat.
Yeah. Usually a lot of it we focus on news, and once we know our equipment is working properly for a while, then we'll start bringing in guests. It's kind of embarrassing when you have a guest like we've had in the past.
And technical issues make it unlistenable.
Yeah,
so.
we don't want that to occur again. We had enough of it doing it once. So once we're confident on everything, then we'll bring guests back again. So hopefully very, very soon.
So hopefully soon.
The other thing, too, is we do upload our podcast the next day on Spotify. So if you're ready to listen to us on Spotify, that is also available as an option. Robert?
Yep.
Let's start with the comet.
With the comet. The comet everybody's talking about?
You mean the spaceship?
No, I mean the comet.
You mean the spaceship.
No. I mean the comet.
No, you mean depends on what circles you travel in, you see.
You see, I don't travel in those circles.
Oh, some people do because it's all over the news, I notice.
I know.
And we've said this before in the last podcast. There's a certain individual that seems to be pushing this idea that this new comet that was just detected a couple of months ago that's coming from a different star system, not from ours.
Not from ours.
And how do we know that, Robert?
Well, basically because of the trajectory, its orbit that it's following. It is an open orbit. It is extremely energetic orbit, meaning it's hyperbolic. So it's zipping in and zipping right back out. It clearly did not come from the Oort cloud or any other bound to our sun's system. And it's coming in fast. We'll go out screaming.
That reminds me of a line from that movie Contact. Whatever it is, it's not local.
Right. It is clearly not local. And, on this topic, I've heard all kinds of crazy things. It's coming in at just the right trajectory for it to be an alien. What would be this right trajectory? How would you know that? And the answer is you can't and don't. So no, there's nothing more special about it than it's from outside of our solar system.
Now, of course, it captures people's interest as only the third object that has been verified to come from a different star system.
Right.
That's why once we get to the point of discovering lots of these things, which we will do, especially with the Vera Rubin telescope that's making observations now from Chile, examining essentially the complete sky in the southern hemisphere every 3 nights or so, we should be able to detect a lot of these objects.
Right. And I've been asked that question, why have we only detected 3 of these things? And the answer is we've only recently had the technology and the equipment making the observations necessary to spot these things. They are moving fast. They are usually dim. And therefore, we only recently got where we could spot them.
Now, unfortunately for this object, it will come closest to the sun when we're on sort of the other side of the sun from it.
Right.
Which prevents us from getting observations from Earth base or even telescopes that's in orbit around the Earth.
Right.
At the moment of closest approach. But
And its closest approach is still going to have it out at about the orbit of Mars.
Yeah.
So it's not really going to get close.
Yeah, which is a good thing because if they get too close to the sun, you know what happens.
They slow down and
You know, sometimes they get perturbed by the other planets in our solar system to the point where it's on all of a sudden an orbit that intercepts the sun.
right, or intercepts us.
And that'll be the end of that. But that's not the case with this object.
Yeah.
So because it's unusual in the sense it's only been the third object that's come from a different star system, therefore there's been a lot of scrutiny on this object to determine what it actually is in terms of its chemical composition and so on.
Yep.
And so there have been a lot of telescopes trained on this object. Last podcast, we showed an image taken with the Hubble Space Telescope, for example. This is a different type of telescope. This is one that's focused mainly in the ultraviolet. The Niels General Swift Observatory, so the Swift telescope. And it made observations both at optical wavelengths and also in the ultraviolet, which is really the important one here. And you see that as the two images on the right. The one that's on the furthest right is labeled as an ultraviolet image. The one that's to the left of that is a V-band image, so that's sort of in the middle of the optical. And what you see in the left panel then is just the front page, if you like, of the preprint that has been submitted for publication describing the detection of water coming from this comet.
Not surprising.
In fact, we've seen that lots of times of water and associated with comets. It's not unusual, as you suggested, but once again, it's consistent with the idea that this object is a comet.
Right. And for those that are curious why we're saying water, is a usual suspect, the most abundant element in the universe is hydrogen. And one of the impurities in the universe that is really abundant is oxygen. Well, what is water? Two hydrogens and an oxygen. Water is everywhere we look out in space.
Now, there's an interesting update with that I'm going to mention here in a second.
Okay.
But the other thing is, one of the things you look for is cyanogen.
Yeah, cyanogens.
And so far, it has not been detected coming from this object.
That's weird.
And that's interesting. Does that mean that it's the Borg on their way inbound? And at any moment, they're going to deviate from their trajectory, and then we'll know it's an alien spacecraft?
Right.
I'm not saying it's aliens, but it's
aliens? No.
No, it's not. It's alien in the fact that it's not from our solar system.
Right. But along with water, the reason this is impressive is because carbon nitrogen molecules, cyanogens, are also very common in comets. So, sorry about that. So the fact that it's not showing up is a little weird.
Now, that reminds me that, Halley or Halley's Comet is one of those most famous comets that are out there. And Edmund Halley convinced Newton to publish basically the orbit of the comet.
Right.
That's where it comes from, Newtonian mechanics and understanding how gravity affects the motion of things around the sun, to show that a comet that was visible every 76 years is the same comet. It's on this orbit that keeps repeating.
Okay.
And Halley even predicted when it should fly by the inner part of the solar system, and he didn't live long enough to see his prediction come true, but it did. And that's kind of the thing that put the nail in the coffin of the idea that objects do travel around the sun, obeying in some sense Newton's laws of motion and Newton's law of universal gravity.
I still remember reading about how one of those passes, it got very large, very bright, because it got very close to Earth. And so the astronomers of the time realized we were going to pass through the tail, and gas masks sold out because people were convinced that we were going to be poisoned with cyanide gas, because it was known that cyanogens were being outgassed. And you can look this stuff up. People bought gas masks, bought cloths to wear over their face and everything because they were just certain of this.
Yeah, that's the point I was trying to get at, the story.
Okay.
And this is from the passage of Halley's Comet in 1910.
1910, okay.
So at that point, spectroscopy, which is the technique that we use to determine the composition of different objects, especially remote objects, is extremely powerful. In some sense, the physics and astrophysics comes mainly through the use of spectroscopy initially.
Right.
Before that, astronomy, in some sense, was bookkeeping, measuring accurate position of things. and measuring their brightness as best as you can at different wavelengths. But spectroscopy really, if you like, revolutionized the field. So as Robert mentioned, it was discovered that cyanogen was part of the makeup of comets, and that the Earth was going to fly through the very tenuous tail of Comet Halley in 1910. And people went overboard.
Right.
And we do that today, so I'm not blaming the generation who lived back in 1910. We do that with lots of things today as well, especially now with social media out there, including, the platform that we're broadcasting on. People say whatever, and then, people pick up on those ideas. But yeah, there was no worry of being poisoned. It's not going to be that. So even if cyanogen molecules, peppered their way through the atmosphere, this fact that they're so rarefied that it would just mix in with the background of molecules that are here already on the Earth.
To me, it just shows that things have been going viral throughout human history. It's just, it used to be a lot harder for it to happen.
Yeah, well, it would be newspapers.
Right.
Right, so the printing press, right? You could print the books that went against people's ideas. Think of Copernicus.
Right.
And that's one thing, right? Then you could jump that up to radio. Right. You could go on the radio before the television came along and said whatever you wanted.
And all of a sudden, it wasn't months or years before news to get across the country. It was hours.
Yeah, or instantaneously almost. If you think of someone listening to a live broadcast on radio, think of War of the Worlds, the famous.
War of the Worlds.
Right, there's one there. And then, of course, television. And now it's basically the internet, right? That people are broadcasting.
Now it really is almost instantaneous, and it's all over the world. So.
Yeah, it's just that not everyone had access to do a radio program.
Right.
Not everybody's going to publish a book or print articles in newspapers, and not everybody had access to television shows to say what they wanted. But now with the internet...
Hey, look what we're doing.
And we're not criticizing people, we're just stating the fact, and we're part of that.
We're part of that.
We're in that boat doing that as well.
That's kind of what I was getting at. We're part of that.
Yeah. So it's interesting to learn how to detect water on this comet. They do it indirectly in that sense, as they look for the signature of OH, hydroxyl, and that is associated with water.
Right.
So it's not like you're detecting H2O emission lines directly or something like that. So it's an indirect detection and inference that there's water there.
To me, that makes sense. And, you're going to dissociate water in the UV with UV light, turn it into a hydrogen and a hydroxyl. So if you see hydroxyl, there's almost certainly an accompanying hydrogen ion somewhere around.
Yeah, and the ultraviolet light coming from the sun is energetic enough. It will break down the water molecule. So the upper atmosphere of the Earth, that happens all the time.
Earth is bleeding hydrogen for that very reason.
Yeah, continuously, and done so ever since the beginning of the formation of the Earth itself, losing the hydrogen. Now, this connection I mentioned about water, some new news that just came out recently. And it goes back to, and you'll be interested in this from a geologic perspective, Robert, is where did the water come from that's on the Earth?
And isotopically, it's matching more asteroid than comet.
So when you think of an isotope, so think of, for example, simplest element, hydrogen. So the most common form of hydrogen, if you remember your high school chemistry and physics, has one proton and one electron on the outside. You can also increase the number of neutrons for that type of hydrogen atom. You can add one, and that becomes deuterium.
Which is
or you can add
a proton and a neutron.
Right, or you could add two neutrons. So it'd be one proton and two neutron. That's tritium. It's very rare, of course.
Right, and it's very radioactive.
Right, exactly. And so if you add neutrons, you're not changing the element. It's when you mess around with the number of protons that you change the element. So if you add one proton, the hydrogen now is helium.
There we go.
And so on, up the periodic table, if you think of that, all the way up to the, let's say, uranium at 92, if you think of just the naturally occurring elements. Now, the thing with water on Earth is, what is the source of the water? And people have argued in the past that it could be comets bringing in a large supply of water. I don't know what were you taught as a geologist, Robert, in terms of where the water comes from? What was the kind of the top ranked hypothesis to explain the water?
It went back and forth between cometary, that comets had delivered it, or asteroids had delivered it. And while I was still at Case Western, was when the paper started coming in saying, hey, the isotope ratios, the oxygen match asteroid sources, not cometary sources.
And so there must have been ideas in the past where a lot of people thought water actually came from deep underground.
Then there was that.
So was the ideal ever made, and it could be I'm dreaming, or I actually read this somewhere a long time ago, that it would provide the lubrication for even the motion of the tectonic plates at some point?
That is definite, because water lowers the melting point of the rock, and so as the rock dehydrates, it also forms well, I hesitate to say it forms a film. That's not really the idea. But as the rock dehydrates, as it descends into the mantle and heats up, the water does make it melt easier. It sends sends the melting curve above the adiabat. And I know these are weird words. I'm trying to think of a way to put it. The adiabat is essentially the least energy necessary. The path of the changing temperature.
So the water, in some sense, is a catalyst,
right,
for the bottom of the plates to become deformable a lot easier,
right,
than without that water, allowing them to essentially flow.
That's yes. Thank you. That's what I was trying to get at. It's the complicated mechanism, but that's the gist of it.
And so the source of water, and we're talking about water on the surface of the Earth now, then people could speculate it came from deep underground.
Right.
That
the issue is that water is volatile. So at some point, Earth should have been, or is hypothesized to have been, fully molten in its formation. So any water that was here originally should have evaporated, should have volatilized out. And so that's why they believed the water had to be delivered. And, you've also got to think of this way. You see the ocean, and on a human scale, that's a huge amount of water. But you got to remember, the Earth's radius is 6,000 kilometers, and the deepest ocean is just a few tens of kilometers. So the water on the surface of the Earth is, by and large, compared to the Earth, a thin film. It really isn't that much.
So is it accurate to say that most geologists would support the idea that the water came from an external source, not an internal?
The bulk of the water almost certainly came from an external source.
New study. Breaking news, Robert.
What
breaking
you got?
news.
What you got? What you tripped me up with?
One of the things you can look at
Okay.
is the deuterium to hydrogen ratio. So this is where you take a hydrogen atom and have a neutron, so a neutron and a proton in the nucleus of the hydrogen atom, that's deuterium, and compare that to the abundance of ordinary hydrogen where you just have a proton in the nucleus. So you can look at deuterium to hydrogen ratio.
Right.
You can measure that for water here on the Earth. They found the exact same ratio for Comet, Pons, Brooks, an exact match.
Okay. So the hydrogen isotopic ratios are matching comets, but the oxygen isotopic ratios are matching asteroids. That's interesting.
Yeah.
That is really interesting. To me, it says that the water on Earth may have been dissociated, come from multiple sources, been dissociated and recombined over the history of Earth. Suggests, anyway.
Well, you think in the very early solar system, we know that we went through a period, what they call the heavy bombardment.
Mm-hmm.
And even I think there's like the late heavy bombardment. Of different episodic sort of time frames that occurred where we had a lot of impacts on the surface of the objects that are surviving today, like the different planets or the moons of planets. Right. And you explain the craters on Mercury for that. You explain craters on the moon and other planets and other moons and even on the Earth, but most of them have been eroded away, of course, right?
Right.
So it's hard to find any surviving from 4 billion years ago.
If they haven't been eroded, they've been subducted.
That's the other thing too. Yeah, so it's interesting that there is some research is still being done, and there was a match for a comet.
Oh yeah, so, I mean, this is job security. I mean, people say, you scientists think you know everything. No, we hope to be proven wrong because that means there's more to figure out.
Well, the source of the water may be a more complicated story than what we had thought in the past.
Which is kind of what I was trying to get at is it may be multiple source issue.
Maybe. But talking about other planets, for example, you have an
Yay.
opportunity coming up in a couple days. So this is in the morning on August the 21st. Hopefully, wherever you are, the weather cooperates.
Right?
You'll be able to see several of the planets in the relatively small region of space, as well as the moon, and even some sort of important stars that we look at. So, for example, this is a view looking east. So obviously, the sun is going to rise in that direction. So you want to get out just before the sun comes up. So make sure
Right.
that they're very early. And you'll see Mercury very close to the horizon. And the reason for that is because Mercury is the innermost planet of the solar system. It doesn't get that far from the sun. So it's going to be viewable just before the sun rises, or just before the sun, just after the sun sets. You'll see it near the horizon if the alignment is correct as it moves in its orbit. And its orbit's relatively fast. I think it goes around the sun like once every 88 days.
88 days. Yeah.
So it's pretty quick. Other things you see here, you see the moon is a crescent phase. So it's almost a new moon phase. Venus and Jupiter, we talked about that also last day. Very bright objects that you see in the east now just before it gets daylight. So they're up. So you'll be able to see Jupiter, Venus, Mercury. So there's 3 planets. In fact, you can also see a 4th planet if you look in the same general direction. What's the 4th planet? You see it there? It's actually on the diagram too, Robert.
Yeah. It's really, really close, too.
You know what I'm getting at?
Yeah, you look down, folks.
It's the
Look
Earth.
down. It's Earth.
So that's the 4 planets.
I used to get
Trick
students
people up on
so
that?
mad at me because it's like, okay, you've seen 5 planets tonight. They're like, 5? Jupiter, Saturn, Mars, or, what's the other one? And I was like, well, look down.
Go out in the daytime and look up the sky. What is the one planet that you can see or feel with your feet?
So
It's the
yeah,
Earth.
we play jokes with that, and
The other thing to notice, what do you see as the famous star that's up there? on the
you
right?
got Betelgeuse and Procyon as
Yeah.
well as Castor and Pollux.
So you know which that signifies, don't you?
It's getting towards the winter.
Yeah, it's the winter constellations you see.
Yeah.
Yeah.
What? In fact, it being up that high tells me that this is an image of what you're going to see. Pretty much as the sky is starting to get too bright to see something like Mercury.
Yeah, that's the thing. Mercury hugs the horizon when
Right.
it is visible. So
And trust me, if you live any place that's got a lot of trees or hilly or anything like that, you will not be able to see low enough on the horizon to see Mercury. It's unfortunate, but there it is.
yeah, it makes it a lot more difficult. You got to look between structures.
You gotta be out where no buildings, out where it's flat as a pancake and no trees.
Yeah. That's why a lot of people have seen Venus. Of course, it gets high enough in the sky and noticeable
Right.
in terms of how bright it gets. But lot less people have seen Mercury. A lot
Right.
less because of that.
Especially in this day and age.
Yeah, for sure.
Too much on the horizon.
Too much. So that's something to look forward to. So hopefully the weather, like I said, cooperates for you. That's always a question mark.
Right?
Probably in most places that you live in the world. This story's been out there, and people asked us to comment on this last time, so I thought I would throw up a slide about this.
Okay.
And this is, so Trump picked Jarek Eisenman to be minister of NASA, and then he pulled that nomination before it went through the Senate
Okay.
for hearing, or it had gone through hearings, I guess, but he pulled it before it was finalized. I guess it's a fair way of saying it, for whatever reason, political reasons, so we won't get into any of that. So the new nomination to be the administrator of NASA is Duffy, and he's the intern NASA administrator now. He was working in the Department of Transportation and kind of just switching over now to NASA. And he came out with an announcement which got a lot of people's attention to say that the United States is going to put a nuclear reactor on the moon by 2030. And this is a fission nuclear reactor, of course,
Right.
not a fusion, which is something we're working on and haven't
Haven't gotten there yet.
gotten to the point where everybody has it and it's available.
Well, we have fusion reactors, but right now they currently require more energy than they
give,
actually produce.
And they don't last a long time either, right?
Right.
Reaction rates.
You can burn a tokamak for, a few minutes.
Yeah, at the most.
Yeah. And you burn 70% more energy than you get out of it.
Actually, we should have a guest on someday to talk about this. This was something
should.
that I remember being, junior high or something in middle school, where we talked about in the future we're going to have fusion reactors, and they're going to be like having a a container or a shed right outside your house, and all you have to do is pour water into it every so often, and that'll be enough to run your electrical needs of your household. And so electricity would become dirt cheap, and nobody would fight over oil again because you really wouldn't need all that oil.
Yep. And the neat thing about fusion reactors is that's the type of nuclear power that would not produce any kind of dangerous radioactive isotopes.
Yeah.
That you would have to then figure out, what do we do with this?
Right. So you get rid of all that radioactive pollution that we have today, and we still haven't solved that issue.
We still
we
haven't.
Store it at nuclear power plant sites.
And we're trying to develop a type of reactor that would actually be able to put those spent fuel rods back to work, because they're still generating a lot of heat.
Yeah, it reminds me of a proposal that people had suggested. I think this goes back into like 70s and 80s, where we could take the radioactive waste, put it into a rocket, launch it, and have it go right into the sun and burn it up, and nobody would have to deal with it ever in the future. And the thing, the problem there, of course, is how many launches would be required to get rid of the waste, and you'd have to keep launching every so often as we generate that waste.
Right.
And then what happens if you have just one failure?
Blows up on the going off the pad.
Or it gets part way up, blows up, and all that. I shouldn't laugh. And all that radioactive material gets spilled into the upper atmosphere and settles down on people.
Well, my response is, as long as it's in the upper atmosphere, it's going to take, one, a long time for it to settle out, and number two, it'll be dispersed. You won't really notice it over background.
Yeah. Do you think politically people would?
Politically people would flip their lids.
So that never happened because we don't have a safe way of doing it. If we had a guaranteed 100% safe way of doing that, it would make perfect sense. The sun would be our landfill, right?
Yeah.
Our dump. We just throw everything into the sun that we don't want.
You say that, and it's less energetic. Would require less energy to launch it out of the solar system than it would to send it to the sun.
Okay, Robert.
Yeah.
Here's a thought.
Yeah.
You look at the spectrum of a star.
Mm-hmm.
What part of the star are you probing?
Ooh.
Ordinary stars. Let's say a main sequence star like our sun. Okay? So you look at the spectrum, let's say you're looking at Vega. That's a main sequence star. It's a little bit hotter, a little bit more massive than our sun. But let's say you take the detailed spectrum of Vega. What is that telling you where those elements are, the composition?
I would have to say, and I'm probably wrong, but I would have to say the chromosphere.
The upper atmosphere.
The upper atmosphere.
Okay.
It's not the photosphere.
So it's the upper atmosphere, right, where those spectral lines are being generated.
Right.
Now here's the idea I'm getting at. An advanced intelligent civilization is on a planet orbiting a star. They have waste. They want to get rid of their material.
Okay.
They develop a technique where they actually have it funneled into their host star. Eventually, you add enough material to the upper atmosphere of that star, what will you see in terms of evidence of that from afar?
Let's see. I would be seeing uranium spectral lines and thorium and, cesium and barium, and would start going, something weird's going on there.
You see the signature of aluminum pop cans where someone drank a lot of Pepsi and Coke equivalent.
Yeah.
You see what I'm getting at? If a civilization used their star as a dumping site,
it would quickly become
those
obvious.
signatures should be seen in the spectral analysis of that star.
Right.
So all you have to do is then run through the library of spectra that we have available for different stars, look for something very unusual.
Yeah, I will agree.
And focus on those objects as targets for SETI.
Yeah. And Extra Bulla has asked us a question. How about using a railgun technology to eject the garbage towards the sun?
Yeah, if you can do it.
If you can do it.
Yeah, and you could think of it being encased in some type of bullet-like object, projectile, that would zip through the atmosphere, right?
And in fact, that would be the way to do it, is not to encapsulate it and put a shell around it, but actually to meld it into the alloy of the projectile.
Yeah, and send that through.
Absolutely.
Yeah, and if you got something, and that would be probably better, more
energy
reliable
efficient
than trying to launch it on a conventional rocket that blows up one every 100 flights maybe on
Something
average
like that.
statistically.
Yeah.
So yeah, it's something to think about in the future. We might have to do that. Because right now
Absolutely.
the idea, of course, is burying it in Arizona. Remember,
Yeah.
Yakima Mountain, I believe.
Well,
it
that
is.
was closed down, but
Yeah, but that was the idea, right?
right.
So you put in a big hole, but nobody wants that in their backyard. So people of
Right.
Arizona protested that and never ever came to fruition. But where are they going to put it now? North Dakota? Well, then we will protest, right?
Right.
So where are you going to put it?
Wyoming, not enough people there to protest.
So
Sorry, Wyoming.
So really, there's no place on Earth without somebody complaining.
Absolutely.
So then in the future, at some point, if we have this problem that we need to take care of it, then doing what Extrabola suggested or something like that is
Right.
just getting it away from the Earth. If you have 100% reliable technology that's not going to cause any problem, then
Fling it.
Fling
I
it.
agree.
And
I
putting
agree.
it into the sun is the way to go.
I mean, that would be one nice thing if we could figure out a way to actually make a space elevator work, because then we could put that rail gun where it wouldn't have to worry even about the atmosphere on a platform at the end of a space elevator and just keep popping off rounds.
Or if you had a way of pushing things like with a solar sail,
Yeah, that
right,
would
and
work
do
too.
something. But as long as the technology is 100%, I know it's hard to do that, but you have to make it literally almost 100% reliable,
Right.
then it would work. It doesn't matter what it is, but you need that if you like reliance.
Yeah.
You can't have the problems. Now, so the idea here is for NASA to put a fission reactor on the moon by 2030. And the idea is you're going to beat China. China is going to put one on the moon by 2035.
Yep.
So there's this whole back and forth business going on now between exploring the moon and between the United States and other countries, mainly China. Let's
Right.
just say what it is. Anybody can look this up. Number one, the United States already beat everybody to the moon with humans we're talking about.
Right.
So that race is over. So I don't see the need of getting into another race again, right? There's already American footprints on the moon.
Or if we are, let's do it. Let's build a permanent or semi-permanent base there. But again, that's energetically prohibitive. So
Well, it'd be
why
ni-
are we getting drawn into that?
Well, it'd be nice to put a base like in Antarctica, a scientific research base.
Absolutely. That's kind of what I was thinking.
And you
of,
could,
yeah.
and one of the ideas that people have, of course, is there may be water brought to the surface of the moon by comets, and that water would survive in these different regions of the moon where it never sees sunlight. And that's what you see on the image on the right, is you're seeing then part of the polar regions of the moon. And in those blue shaded regions is where the interior of these craters are permanently in the shadow.
Right.
They don't see direct exposure to the sun. So there's potential that ice could be there if under the soil a little bit,
And,
right?
And
But
that's
at least something you can tap into in the future as a resource.
and putting humans in space, that's one of the big issues is water is heavy, 8.8 pounds per gallon. It is heavy stuff. So it takes a lot of energy, a lot of cost to take water with you. So if we've got someplace that already has water there, that lowers the cost.
So if you bring bear, is that just as heavy, Robert?
I'm afraid that's that's almost as heavy.
What if I bring light bear?
Oh Lord, I should have known you were going there. I should have known.
But so if you have some kind of energy generation mechanism that's set up in these polar regions, you're in the shadow, you can't use solar panels
Right.
typically because you never get any sunlight. And the other problem is even if you had it in the equator of the moon, the day is 2 weeks long, but then the night is 2 weeks long. What do you do in the 2 weeks when the sun is not above the horizon? You're going to freeze to death because you have no power.
Right.
You have to store it in huge
I
batteries
was about
or
to say,
something. Right?
that would take some big batteries.
So we're going to need probably a nuclear reactor at some point.
Right.
In fact, we use that already in space. It's not like we don't launch that stuff already, and mainly it's used to power like spacecraft that go to the outer solar system,
Right.
radioisotope thermoelectric generators on the Voyager spacecraft, on Pioneer, and so on and so forth. It's endless, right? All the
Yep.
ones that we send up. So we've used it before. So it's not weird that we would have to do this. It's just a logical thing. I don't know why they made a big deal about it. It's
Me
just
either.
it's got to be politics, I guess. Any way to beat another country doing certain things, I guess that's the name of the game nowadays.
Right.
But anyways, it's out there.
And, I've long been one that said, let's put some power generators on the moon. You know, another thing we could do, because another thing that could be done is you could beam that power back to Earth using microwaves
Right.
and receiving stations. Now,
Yeah.
yeah, this is definitely a system where we're not talking double or triple redundancy safety protocols even. We're talking, 5, 6 levels of this gets shut down if it twitches,
Well, this was an idea of doing that, having large satellites in orbit around the Earth with solar panels and beaming the energy
Beaming it
down to
down.
the surface. You just hope that you don't fly through the beam if you're on an aircraft.
Right.
So
And that's what I was talking
Yeah.
about. We're talking 6 levels.
or you're not
of-
going to have any children.
Yeah, 6 levels of, it twitched. Shut it off.
Extra bullet mentions New Jersey. Is that where we want to dump
That's
our
where he wanted to dump the radioactive
Why is New
waste.
Jersey? I wasn't born in the United States, so I don't get it. Why does everyone pick on New Jersey?
Hey, I'm from the South. You may as well just say the North,
Is that the New York people pick on New Jersey?
New York people pick on New Jersey, and Extra Bulla, if I'm remembering correctly, you did live in New York for a while.
Oh, there you go. You've been brainwashed.
He got out though, so I won't say where he is now, but he got out.
So he's smarter than the average bear, right?
There you go.
Now, talking about China and their sort of wishes to go to the moon, China is actually doing this. They're building the hardware and developing the technology to land on the moon that they predicted in the year 2030, that they'll
Okay.
have Chinese astronauts on the surface. And to illustrate that, just a few weeks ago, China is testing their lunar lander. And that's the image you see on the right. The one on the left, of course, is just an artist drawing of that. So they're actively out there testing the equipment. And they are further ahead than the United States in the
Yes.
sense that with the Artemis program, we don't have a lunar lander, right? 2 companies have been, if you like, given contracts to develop a lunar lander. Blue Origin is one of them. And the other one, of course, is SpaceX. So SpaceX, which we'll talk about in a few minutes here, that's part of the Starship idea, is they'll be able to take astronauts from the gateway, from lunar orbit, and have them land on the surface of the moon and then back up to the gateway. But, China is actively doing that, and you can see the test being run there on the right. That's an actual image. So
And I know it's not politically correct for me to say this, but more power to them. I hope they do it. Maybe it'll light a fire like Sputnik did under this country about doing scientific research.
Well, if I'm not mistaken, I remember when the ideal of International Space Station, which went through many sort of incarnations, moon base alpha, that kind. So it was Alpha or Freedom International Space Station. I think it was called Freedom at one point, and all this. Ronald Reagan, I think, named it that, and there was argument that was made, and if I'm not mistaken, I think both Neil Armstrong, the first man on the moon, and also John Young had spoken out in public and said, it may not be a good idea to have the Soviet Union scientists, Russia ultimately, to be part of the space station, that we might be better off in competition with other countries to push the technology development a lot faster and better
Right.
than trying. It's like if we do it all together, there's no real motivation to do things. There's no, you're not beating anybody, right? In that sense.
And my response is that's hogwash. There's always the human deal of being the first one to do it. I mean, we rush to get papers published because of that.
Well, don't forget, though, it's a political decision.
Right.
If you're in
True.
competition with another country, then maybe the public are going to be more keen on being able to give you money to beat country X rather
Right.
than say, oh, we're all sunshine lollipops, we're all going to hang together and eventually we'll get there. Let's kick in some minimal amount of money every year to the space budget.
Right.
And yet it just slows down the progress. So you could argue that, tortoise and hare, but
Yeah.
who won that race?
The tortoise won that race.
So who's to say?
I would prefer to have slow and steady than intermittent bursts. Whereas Extra Bulla has asked, is it true that we forgot how to get back to the moon like we did the Apollo days? And the answer is no, we didn't forget how. We lost the expertise as those guys retired and
Past.
died.
Yeah.
A lot of the equipment was dismantled. So a lot of the computers and the programs, therefore, were lost because the equipment was dismantled. So there's a lot of that institutional loss that happened when suddenly the idea of going back to the moon appeared again. And all we had was the space shuttle, which people don't understand. The space shuttle did exactly what it was supposed to do, which was get to low Earth orbit. It lacked completely anywhere near the amount of power needed to get to the moon.
Well, I'll push back on one little thing with
Okay.
the space shuttle. It was sold to Congress as a cheap and
Yes.
reliable way to getting into Earth orbit, and cheap it never was.
Right. And it did accomplish a lot of goals, but it did not accomplish the main goals that allowed it to be sold. But all of the attention and everything was directed towards it starting in about the 70s, mid 70s.
Well, Nixon is the one, right?
Okay.
Nixon made the announcement that at the time about supporting the space shuttle. That was done during one of the Apollo missions. I think John Young's flight, which is what, Apollo 16 or something?
Something like that.
That they
yeah.
radioed to him and said, by the way, Congress passed the appropriation budget, which included money for the space shuttle.
Right.
And Nixon was presented with, if I'm not mistaken, the space shuttle and the space station to fund both. So the shuttle was just like it says. It was to go from the Earth to the space station, but they could only afford one, so they built the shuttle.
Right.
And people would argue with no place to go except low Earth orbit, and that was as exciting as going to Pittsburgh, not picking on Pittsburgh.
Right.
But it was exciting as a trip to Pittsburgh. Who cared? The public lost interest because of that.
Yeah. And you're exactly right. I mean, the moon launches became second nature. We're going there. So
And the shuttle, in terms of its cost per pound, that was predicated on the fact that you would launch them every week or two.
right, which never
You could never
transpired.
turn around. In fact, there was a lot of pressure on the schedule, which ultimately, and it's in the review that they've done in the commission on the Challenger, that led to the explosion of the Challenger in January of 1986.
Right.
It was because of the pressure to launch often, because
Right.
that's what was promised. And if you launch often, the cost per launch goes down, and the cost, per pound of getting material into space also decreases. So that was sold on that idea. And I think, I'm not blaming people, but I think engineers realized back then there was no way they could do that.
Right.
That
Well,
it would be an experimental spacecraft until you had, 1,000 launches or something,
Right.
which it never reached.
Which it never reached. And Extra Bull is also asking, it was cheaper when they used piggyback the shuttle on those giant jets to launch. And the answer is no. It's not cheaper to do that because the jet actually doesn't get it high enough for it to then use its main thrusters to get into orbit. So that's why it was testing when they were doing that, is those shuttles did not get into orbit. They just went up a little bit and then tested and showed that they could land them like an airplane.
Yeah, it was just a approach and landing test that they did off the back of the
Right.
airplane. The other thing it reminds me of is Lockheed Martin advanced the technology of the Pegasus rocket that launched from underneath like an L-1011
Oh, right.
L-1011 jet. And you can tell it doesn't work cost effectively because nobody uses it.
Right.
It's all being launched by SpaceX now because it's a lot easier and cheaper and more reliable.
I was about to say there are people using it because Virgin Galactic, I believe, uses it for their suborbital flights.
Yeah.
So they're still not going into orbit, but they get their craft off the ground, then launch it a little bit higher, get it into suborbital. So you're still up, where you can see the curvature of the Earth and space is black and all
Yeah.
of this.
But it's used, I mean, as far as I know, and this is military now, that the United States can drop off a solid propellant missile from the bottom of a fighter jet, and it's designed to go up into space and knock out satellites, the anti-satellite system.
Which I hope they never use because
Well, they've already tested
I
that.
know, and it scattered how much debris?
Yeah, and other countries have tested theirs as well.
Yeah.
But is it easier to do that, or is it easier just to launch the rocket from the ground and go up?
Right.
That's the idea. Or maybe, I guess, if it's on on the bottom of a military jet, you can fly somewhere around the world and not having to wait for the alignment to be right to launch something from the ground.
Right.
Right? You could go somewhere else and then launch it. Maybe it's easier that way from a military point of view.
Right. It's just me. I'm sitting there going, we're putting enough junk up there that it's starting to become dangerous in orbit.
Yeah, sure. And yeah,
where them blowing up satellites is just producing that much more shrapnel.
yeah. An extra bullet mentions also about railguns, but of course, it's not good for humans to sit on a rail. The amount of number of
doing
G's.
20 G's. It's not a bad idea, but
You wouldn't need Botox,
no,
at least for a period of time.
It'd stretch those wrinkles out, as the movie Space Cowboy said.
It would be pretty interesting. Now, speaking about SpaceX and Starship, so we have another test schedule coming up on Sunday. If it doesn't get delayed or changed, August the 24th. So this is the 10th flight. Hopefully this one will go better. They have a failure, late into the mission, the last few of them. So
yeah, we'll have 100% failure rate on the last few missions, which
it hasn't been good, but I mean, they are pushing the technology.
they are.
But ultimately, it's going to be one of the
It's going to be one of Blue Origin or these guys.
that'll land on the moon. And so we want
Absolutely.
this technology to be developed, right, to do that. So we'll see. But hopefully it works out, because that is supposed to lower the cost per pound of getting material into space and so on.
Whichever one of them goes first, I hope they both end up there, because exactly. You start having competition, prices start going down.
Yeah, that's the hope anyways. But yeah, we have some more work to do. It's not ready yet, that's for sure.
Yep.
Now, speaking about work to do,
Uh-oh.
here is a study using the James Webb Space Telescope of very high, most of them are high redshift objects. And they're called Lyman-break dropouts. And these objects are very bright. So what is that all about? Well, if you look at the brightness of an object as it relates to wavelength or frequency, what we call the spectrum of an object, if an object is at rest relative to us, if you go way out in very short wavelengths, let's say around 912 angstroms, which doesn't mean a lot to people, but
Right.
it's way off into the ultraviolet. Okay. If you have a source that's emitting that type of light, that light has enough energy that will ionize, strip away the electron from a hydrogen atom. So any hydrogen that's out in space then would be ionized by those type of energetic photons, particles of light. And so the idea here is that if you have a star system like a galaxy that's producing photons of very short wavelength, shorter than 912 angstroms, those photons will get absorbed by the hydrogen that lies between us and those distant galaxies. So they never reach us.
So there's a break in the spectrum.
Right, there's a break in the spectrum. So that means you will not see really features then that are shorter than that wavelength,
Okay.
because those photons are getting absorbed. They're interacting with the matter that lies between us and those sources. Now, we can track the movement of those features as a function of wavelength by just sampling the spectrum at different points. For example,
Through different filters.
a way
Yeah.
of doing it is through different filters. So if you look at if you take an object then, and it's at very high redshift, the 912 angstrom photons will not be at 912 angstroms, because they are redshifted heavily if they're really, really far away.
Probably be like 2 or 3 micron.
Yes, they could be redshifted out into the infrared if they are far enough.
Right.
So we can use instruments like the James Webb Space Telescope. Number one, it observes mainly at infrared wavelengths, like with NIRCam. And the other thing it can do is it has a very large aperture, so it can see faint sources. So it can look for things that are faint because they're far away, but at long wavelength.
And if they're far away, they're moving away from us very quickly, so there's a high red shift.
Right, so these features are shifted way to much, much longer wavelength. And what you can do is you can take images at different wavelengths, different filters, and that's what you see on the right, of regions in space, looking for, well, if there's a redshift of this value, and you can test that by taking a spectrum of it, if you can get a spectrum of it, then I should see that 912 angstrom, the Lyman line, the Lyman limit line, right? And if I don't see that, then it must be at even higher redshift. So I can go through my whole filter section looking to see all of a sudden where is the object at.
Yeah.
And it just brackets the range of redshifts or distances that this object is at.
Which is what we want, because that gives us error bars.
So if you don't know any of that, if it seems like gibberish, just think of it. We have a way to crudely estimate the distance to these objects by taking images of them in different filters.
Okay.
Okay? And what they discovered was that in this study, I detected 300 of these objects, that a lot of these objects, which have been followed up, of course, are at high redshift, indicating, number one, that there are these Lyman-break dropout objects. So the fact that they're at high redshift means that light that has wavelengths shorter than 912 is essentially completely absorbed. But they also, and this is the important thing, they've also determined that when we do see them at wavelengths longer than that limit, they are too bright. Too bright meaning they're not consistent with the modeling that we expect of that galaxy.
We're learning all kinds of nifty stuff.
Okay.
Heck yeah.
So they are very bright Lyman-break dropouts, hence the title.
Okay.
So it is a sample of these, in some sense, weird type of objects, and they're probably mostly galaxies, but you don't know that till you confirm it.
Right.
That are unusually bright at these wavelengths. So it would be at the ultraviolet wavelengths if they're at rest with no redshift, but because they are moving away from us rapidly due to the expansion of the universe, they're way out in the infrared, where of course JWST can get a good image of them.
Right.
So they're finding these objects then that are weird. And that's what you look for as a scientist, right?
Absolutely. You want the weird.
The needle in the haystack. Remember, we had a quote once, I don't remember that, I think it was from John Wheeler, which said basically, if you want to start doing something in science, if you're new, look at the things that are different than everything else.
Right.
That don't conform to the average object in terms of their properties.
I often tell my students the interesting things happen at the interface. You want to look where things are changing, where they're shifting, because that's where the interesting things are going on.
So with follow-up study then, we'll be able to tell a lot more about the properties and see if this really, if you like, adds extra evidence in some sense that we have already. When we look at very high redshift like black holes, we see evidence for that we really need to change our ideas about galaxy formation. It says nothing about the universe, so don't think this implies the universe is 100 billion years old and not 13.8. This means that we don't have all of the steps done in detail of how you form these different types of galaxies and objects at very high redshifts, great distances away from us.
It doesn't call into question the universe. It calls into question how galaxies are made.
Yeah, exactly. And speaking about the James Webb Space Telescope, we also have a follow-up study that was done on a relatively nearby planetary system. This is the TRAPPIST-1 system. It's only about 40 light years away. I say only, but think of the diameter of the Milky Way is 100,000 light years.
Right.
Right?
We could get to this system in a few hundred years with the right propulsion system.
Yes, and we can. And the neat thing about it is that it has 7 planets in orbit around the host star, and of course we like to keep things simple, so we label them as with letters, right?
Right.
As you see there in the
Lowercase
diagram.
letters in the case of planets. If it was other stars that were in orbit around each other, it's capital letters.
Right, so you can see that in the top panel, and then on the bottom, this is on the right, and then the bottom drawing is one of our solar system for comparison in terms of the scale. And it's relatively similar in terms of how far out the different planets are from the host star, that maybe one or more of these planets in the TRAPPIST-1 system could potentially have an atmosphere, and maybe one of those could potentially host life.
Right.
Who knows?
Who knows?
Right? You don't know till you look. That's the thing. Now, the one planet that seemed to be a good candidate of being maybe a little bit like the Earth in some ways, especially in terms of its atmosphere, was the TRAPPIST-1d planet. And the JWST then has observed this planet transiting in front of the sun relative to the telescope.
Right.
And it has measured then changes in the brightness of this planet. And from that, it can infer the spectral features then by looking at this. And so it has found that, for example, that the planets has either an atmosphere where light is reflected off of the high albedo clouds in the upper atmosphere, or it has very little atmosphere at all.
Right.
So they looked at it, looking for spectral features of this planet, and didn't find any. So it lacks, if you like, atmospheric features
Right.
coming from the planet itself.
And it's sitting there telling you it's looking for things like methane, water, carbon monoxide, carbon dioxide, and sulfur dioxide. And yeah, all of these have very strong infrared signatures in their spectra. And if they're not there, I'm not even thinking clouds, because you should still see some kind of reflective spectra off of clouds. So if there are clouds that are not made of a very uncommon compound like ammonia or something, at least that's my guess.
Yeah. So, I mean, this system, number one, is probably one of the top planetary systems to look at
Right.
in detail. And
Well, you've got three of its planets are in that quote unquote Goldilocks zone,
yeah, the habitability
zone. So, and D is not one of them, I'm noticing. I just noticed that. I put together these slides, put them into the system for you, and hadn't noticed that.
Well, it's on the edge. It's really close.
It's on the edge.
And that habitability zone, that's a little funky. That depends on how you, I mean, it's an M-class star.
Right.
So it's a little funky how you count that, because you can have planetary sources of energy that's unaccounted for.
And you can have atmospheric trapping, greenhouse effects,
Yes.
and things like that. So, or you can have high albedos that they reflect more light and therefore don't retain the energy.
So that habitability zone can be broad, and that is the conditions conducive enough for life to survive as we know it. That's what the habitability means.
Now, the issue is that with this being an M dwarf, an M-class main sequence star, is all of these planets are close enough that they're what we call tidally locked. They show one face to their star like our moon shows us one face. Doesn't mean they don't rotate. It just means they rotate at a rate that equals their year. So there's always this question of, shouldn't that mean any atmosphere boils off because it's always being heated, and on the night side it freezes out because it's never seeing heating?
And the other interesting thing is, if we've detected through different techniques the presence of literally thousands of planets,
Right.
and there's not a single one of those planets that is like the Earth, identically.
Yes, you are correct.
So it makes you think, how rare is the Earth? And I don't mean that there's life on the planet. I mean having the mass, the atmosphere, and the distance from its sun in terms of how much energy it receives to make it essentially Earth-like. How many of those are actually out there?
Right. And
There could be lots. I don't know.
And the other question to me then is how requisite is that for there being life?
Yeah, to support life.
I mean,
But-
two Earth masses, but you've got atmosphere and water, you may get life still.
But, if you're going to start with something that you know.
Absolutely. You start with what you know and what's easy to calculate.
Right, so start with something that's almost as close as being like the Earth as possible.
Right.
But how rare is that? Is that 1 in 10,000? Is that 1 in 100,000? Is that 1 in a million planets are like the Earth?
Right.
So it's interesting from that point of view. But as more gets discovered, statistics improves, and we'll have a better understanding of that.
Yep.
Hot off the press, Robert.
Yeah, this you hit me with this one right as we were prepping the slides.
More breaking news, and it's another discovery from the
James Webb. Yeah.
So what James Webb has then been announced today, has detected, is a new moon for the planet Uranus. Or you could say it a different way, but it doesn't sound good.
Right.
So this
It
puts
gets a lot of giggles.
this puts the total number of moons orbiting Uranus at 29 currently, and I'm sure there's more than that.
Oh, certainly. Yeah.
They just had a big mother load of moons discovered around Saturn.
Around Saturn. Yes.
So it's well over 100, well over 100 moons. I forget the exact number now, but it was like 129 or
Something
some
like
huge
that.
number. So yeah, there's a lot. And then of course Saturn has the rings. So if you want to be technical about it, you could count every little ring particle, every iceberg that's in orbit around Saturn as a quote unquote moon. Right?
Right.
You can do that. But I like Uranus, and the reason why I like Uranus is the moon that you see there that's on the far left, and that is Miranda. Do you remember what Miranda looks like?
It looks like the Death Star.
No, you're thinking of something else. That's around
okay.
Saturn. Mimas, you're
Mimas.
thinking of.
I'm thinking of Mimas.
Miranda's the moon around Uranus where it looks like it was broken into a bunch of pieces and then just glued together by a child or something.
Which is probably exactly what happened.
And it's cool. It's the only one in the solar system that's like that.
Mm-hmm.
So we should show an image of that next time when we talk about the moon.
We should. I'll look for it.
It is. And that was discovered by the Voyager. Mm-hmm. Voyager 2 when it flew by Uranus.
But yeah, it looks like a jigsaw puzzle.
Well, now here's a quiz for you. You ready?
Oh, Lordy. Okay.
And what year did Voyager 2 fly by Uranus to give us our first really close-up view of its moons and the planet?
83?
Nope.
86?
86.
Okay.
Now you got to ask, how do I remember all that?
I remember I was a junior in high school then.
You know how I remember that date?
How?
Because all of the space reporters at the time were in the Jet Propulsion Laboratory reporting on the new findings coming back about Uranus when the Challenger blew up. And all of them had to rush back to like Houston or the Kennedy Space Center to report on that.
Okay.
So yeah, that was the same. That's how I connect those dates like that. So very, very interesting. Now, if you want to learn more about this stuff that we talked about at the podcast, a good way of doing it, look at this beautiful slide.
This is our campus.
We thank Tracy for putting this together for us. It was a new slide that we got today. So if you come to the University of North Dakota, you take all of the lovely and great programs that we have going on campus and also online. And you can learn about almost anything you want by coming to UND.
You can come meet us, you know?
Yes, you can meet Robert and shake his hand and get his autograph.
Right.
Because he's an author.
Well, we'll be soon.
Yeah, so you can take advantage of that. Now, our next podcast will be next Tuesday on August the 26th at 5 o'clock Central Daylight Time. So if you want to be able to interact with us through the chat, of course, then connect to us at the time that we are broadcasting live. Now, we always leave a quote at the end.
Okay.
This is a quote from a recent quote. Now, usually we get ones that several hundred years old or something like that, but I actually picked a quote from somebody much, much more recent. It's actually by the co-author of the TRAPPIST-1 paper that we just discussed.
Oh, okay, cool.
And it's by Ryan McDonald at the University of St. Andrews. Mm-hmm. And here's his quote. While TRAPPIST-1d may prove a barren rock illuminated by a cruel red star, the other planets, TRAPPIST-1e, F, G, and H, may yet possess thick atmospheres.
Absolutely.
Now, if you like this podcast, please give us a thumbs up. Smash that
like button.
Give
us a comment. Tell us what you like and what you don't like, what you might want to see in future episodes.
Subscribe if you haven't subscribed.
Yep.
And please join us next time. Thank you very much for watching.
Have a good evening, folks.